Hi there, senior high school students. Welcome! This video is about general mathematics for senior high school grade 11. Before we start, do not forget your pen and paper to write your solutions later on, and remember, you can always pause and play this video whenever necessary. So, are you ready? Let's start! So our topic is about introduction to functions. Do you have any idea what a function is? Let us first recall the different terms related to functions. Oh, let us complete this word. A rule that relates values from a set of values, domain, to a second set of values, range. What is this word? Well, we have our clue. Starts with letter R and ends with letter N. This is relation. Well done! How about this? A pair of objects taken in a specific order. This is ordered pair. Correct! Now to clarify about ordered pairs, let us have an example. Remember that an ordered pair is a sequence of two elements. Here we have 1 and 2. They are enclosed in a parenthesis and separated by a comma. Now how about this? A collection of well-defined and distinct objects called elements that share a common characteristic. You've had this when you were in your junior high. The answer is set. Great job! Now what is a set? Well, simply put, a set is a collection. Look, this is an example of a set of ordered pairs. They are enclosed in set brackets. Now, can you recall this one? We have your clues again. D and M. The set of all X or input values. This is domain. Correct. D-O-M-A-I-N. Domain. Now let's review about domain. Look at this set. We have 4 ordered pairs. 1, 3, 4, 1, 2, 0, 7, 2. Now what is our domain here? The domain is the first element for each ordered pair. Meaning to say, they are the X values. So 1, 4, 2, and 7 serves as domain. Next, how about this? The set of all Y or output values. This is range. Great job! Now, using the same example we've had for domain, we have this set of ordered pairs. We already have 1, 4, 2, and 7 earlier as our domain. Now this time, the range here are these values. The second element of each ordered pair or the Y values. So that will be 3, 1, 0, 2 in this example. Now that we have recalled these terms, we are now ready to answer the question, what makes relation a function? By definition, a function is a relation between a set of inputs and a set of outputs with the property that each input is related to exactly one output. Typically, functions are named with a single letter such as F. So a function is a special kind of relation because it follows an extra rule. And just like a relation, a function is also a set of ordered pairs. However, take note of this. Every x value must be associated to only one y value. Again, always remember this. It is only a function if every x value is associated to only one y value. Now, illustrations will help us learn functions easily. So here we have mapping, ordered pairs, and graphs. Let's start with mapping. In mapping, it shows how the elements are paired. It's like a flowchart of a function showing the input and the output values. Like this. The domain for the first set and the range for the second set. Now, using mapping, let us identify if this is a function or not. How do we do that? Again, every x value must be associated to only one y value. Now, let us check if every element in our domain is associated to only one value in our range. So look, our domain A is being paired to 1. Our second element B is being paired to 2. C is being paired to only one y value in the range, which is 3. And lastly, D in our domain is being paired to one y value in our range, which is 4. So as you can see, every element in our domain is being paired to only one value of y in our range. So that means this is an example of one-to-one correspondence, and it shows that this is a function. Now, can you identify if the given example is a function or not a function? You may pause this video. Okay, so this is still a function. Why? So as you can see, every element in our domain is being paired to only one value of y in our range. So A is being mapped to x, B and C are being paired to only one element, which is y, and D is being mapped or paired to Z. So every element of the domain is being mapped to only one y value in our range, meaning to say, for every input, there is only one output. And this is a type of many-to-one correspondence. For this example, we have two elements in our domain, B and C, that has the same element in our range. Take note that this is still a function because every element has only one output. I hope I made that clear. So, this is a function. Now try to identify if this is a function or not. You may pause this video. Okay, so this is not a function. So earlier, we had many-to-one correspondence. Now this time, you call this type of correspondence as one-to-many. Now let us try to focus on our element 3 in our domain. So as you can see, it is being mapped to 5 and at the same time to 7. Now that means that this element 3 has two outputs, 5, and 7. And this is clearly a violation of the definition of a function, because 3 here is being paired to 2 values in our range. So I hope this is clear. Now let's move on to another way of determining functions, by set of ordered pairs. Now this is easy. First step, let us identify the x and y elements of the given set. So we have 1 as x sub 1, 3 as y sub 1, 4 as x sub 2, 1 as y sub 2, 2 as x sub 3, 0 as y sub 3, 7 as x sub 4, 2 as y sub 4. Now why is it important to identify our x and y values in each ordered pair? Because these values, the domain, are the critical values to identify if it is a function or not. So look at this. We have 1, 4, 2, and 7 as the x values, and no x value is repeated. So every element is distinct or unique from the rest of the domain. Thus, we consider this as a function. Now try to identify if this set of ordered pairs is a function or not. Okay, so first step, let us identify the x and y elements like this. Followed by, yes, we are going to identify the x values or the domain. Now here, notice that 3, which is an x value, is repeated. It is repeated. For that element in our domain, we do have 2 different outputs, which is not anymore a definition of a function. So this is not a function. Now this time, let us focus into another way of determining functions. How do we identify if the given graph is a function? Yes, that's right. We are going to use the vertical line test. Functions can be determined using graphs, and we can use this vertical line test, which is a special kind of test, using imaginary vertical lines that should touch the graph only once. Otherwise, it is not a function. Now, what do I mean by that? If the vertical line hits 2 or more points on the graph, it is definitely not a function. Let us look at some examples. Okay, so let us try to check if this is a function or not using a vertical line. Yes, the red line there is our imaginary vertical line. It is not part of the graph. We just made that to test if the given graph is a function or not. So the point there is here, which means that the vertical line touches the graph at that point only once. Now how about we try to move the vertical line? Yes, again it only touches the graph once. So here you can check if it's a function if at any point of the graph, the vertical line would only touch the given graph once. Now how about there? Yes, it only touches the graph once. Therefore, we consider this as a function. Okay, Now, how about this graph? Is this a function or not a function? You may pause this video. This is not a function. Why? As you can see, the vertical line touches 2 points in the graph. And that means this is definitely not a function. Now, how about this graph? Is this a function or not? You may pause this video. Alright, so this is not a function. Since the vertical line touches the graph at 2 points, this is definitely not a function. So now that we are done with determining functions, we are now ready to our next lesson, which is evaluating functions. But before we dig deeper about evaluation of functions, let's recall significant points about our first lesson that is about functions. Now, function can be related to the picture that you see on the screen. What is it? That is right. This is a machine. This is a function machine. Why? A function is like a machine that relates this strawberry, which is your input, to this, an ice cream, which is the output. So every time our input gets inside the machine, it follows a rule that leads to our results or our outputs. I repeat, our input gets in, follows the rule, and then gets out as an output. So remember our function machine to recall the meaning of functions. So how do we write and read functions? So let's have this. You can write it using this function notation, and you can read it as this. So this is f of x is equal to the given. Again, this is f of x is equal to the given. So another way of writing this, we can also use g of x and h of x and other letters. So traditionally, functions are referred to by a single letter like the ones shown on the screen. However, you can also use any other letters to name a function. So let's have an example. So we have here this function, and you read it as f of x is equal to 2x plus 1. One more time. F of x is equal to 2x plus 1. Now, you can write that in this form. That is, y is equal to 2x plus 1. So notice f of x and y. So I mentioned that you can write this, right? So meaning f of x can be rewritten as y. So f of x notation is another way of representing the y value in the function, which means these two are considered as equivalent notations. So they mean the same thing. Now let's go back to f of x is equal to 2x plus 1. So here, x stands for the input. So similar to the input in our function machine, and this time, this would be our output, 2x plus 1. Now let's try to evaluate functions. Let's have this. The function is f of x is equal to 2x minus 4 if x is equal to 3. So another way of presenting the question if you're asked to evaluate a certain function is like this. Find f of 3 if f of x is equal to 2x minus 4. So if you encounter this question or this statement, it means the same thing with the previous statement. Now let's evaluate the function. So step 1, copy the given. So the given function is f of x is equal to 2x minus 4. So step 2, replace 3 with x. So now we have f of 3 is equal to 2 times 3 minus 4. Next, perform the indicated operation. So f of 3 is equal to 6 minus 4, and 6 minus 4 is equal to 2. Now let's have another example. So we have g of x is equal to 3x squared plus 7 if x is negative 1. So once again, step 1 is copy the given. So the given function is g of x is equal to 3x squared plus 7. Step 2, replace negative 1 with x, meaning to say we substitute the values of x, which is negative 1, in the given equation. So now we have g of negative 1 is equal to 3 times negative 1 squared plus 7. Next, the third step is perform the operation. So g of negative 1 is equal to 3 times negative 1 times negative 1. We have 1 plus 7. So 3 times 1 is 3 plus 7 is equal to 10. Okay. Now how about this? You may pause this video and answer. Okay, so the answer there is 1. So how did we come up with that? So this is the solution. So from the given function, when x is equal to 2, we copy the given. So that will be this. 3x minus 5. So replace 2 with x. We have 3 times 2 minus 5. And 3 times 2 is 6. Minus 5 is equal to 1. Okay. So now it's your turn. I prepared a 10-item assessment for you to work on, for you to check if you fully understand our lessons. So here's the first 5. You may pause this video and copy the given in your mathematics notebook, or you can have a screenshot of this. Now here are the other 5 items. You may answer these on your available time, and I hope everything was clear. I know that you can do this. See you on our next lessons!